ආයිබෝවන් හැමෝටම අද පැවැත්වීමට නියමිත වෙන්නේ කෙමිස්ට්‍රි දේශනය. ඒ වගේම කියන්න ඕනේ අපේ නැනපවර ෆවුන්ඩේෂන් එකේ නිර්මාතෘ වන ප්‍රභාත්නන්ද තිලකරත්නසගේ සංකල්පයක් යටතේ තමයි මේ වැඩසටහන ක්‍රියාත්මක වෙන්නේ. සීලුම් පාසල් ආචාර්ය මණ්ඩලය අපේ නැනපවර ෆවුන්ඩේෂන් එකත් එක්ක එකතු වෙලා ඉන්නවා. ඒ වගේම උසස් පෙළ සියලුම විෂය ධාරාවන් වල සියලුම විෂයන් සඳහා දේශන සංවිධානය කරලා තියෙන බවත් මේ වෙලාවේ සතුටින් කියන්න ඕනේ. ඒ වගේම කියන්න ඕනේ දැන් ඔයගලට අපේ ඉස්සරහට තියෙන දේශන ගැන දැනගන්න ඔයගලන්ට අපේ ටෙලිග්‍රෑම් ගෲප් එකට සම්බන්ධ වෙන්න පුළුවන්. ඔයගලන්ට අද දේශනයට සම්බන්ධ වෙන්න ලින්ක් එකක් ඇවිල්ලා අන්න ඒ ලින්ක් එකට තියෙනවා ටෙලිග්‍රෑම් ගෲප් එකට සම්බන්ධ වෙන ලින්ක් එක. ඒ ලින්ක් එක ක්ලික් කරලා අපේ ටෙලිග්‍රෑම් ගෲප් එකට සම්බන්ධ වෙන්න පුළුවන්. ඒ වගේම Zoom ඔස්සේ පැමිණෙන්න බැරි අයට කියන්න රණපවුරු YouTube channel එකෙන් බලන්න පුළුවන් කියලා. ඒ වගේම අපේ YouTube channel එක subscribe කරන්නත් අමතක කරන්න එපා. එහෙනම් මේ ආදරණීය ඇරයුම ආචාර්ය ටශිකා බාලසූරිය.
I today. Now I'm going to do the chemistry paper, the structure of the paper, because first of all you have to identify the structure of the paper that you are going to face on your exam 2022. And I'm going to discuss about the structure of the paper and the things that they are coming under the structure of this paper. And then after the second session is coming with the Vespa Theory, because that is also coming as your chemistry concept that you have to cover according to your first lesson. Okay, now first we'll move to the structure of the paper. Okay, now you are sitting your A-level on 2022, and already you know that there are two papers, paper number 1 and paper number 2. Paper number 1 is coming with 50 MCQs, 50 MCQs, and all MCQs are coming with 5 options. You have 5 options in each question, and you have to select only one answer in your answer script, and clearly you have to write it. Write that, mark the correct answer as the one answer should be there. Then after, you know that the normal structure is there. 1 to 30th question, it comes as a normal MCQs, and it has got 5 options in there. And 30th to 40th question, out 10 questions are there coming with statements, and there are 4 statements called 1A, B, C, D, and like that. And you have to take the combination, and according to the guidelines they are giving in your paper, you should have to select the correct answer in there. And the last 10 questions are coming with the statements. In there you have to think logically and take the relationship in between the statements. Normally they are giving 2 statements, first statement and the second statement. It can be related with the first one or it can be not related with the first one. Whatever, you should have to think logically what is the relationship in between those 2 statements based on one matter. Okay, then after you can select the correct answer in there and mark it in your answer sheet. That is how the structure the paper number 1 is going on. And especially you should have to think about here, one MCQ is coming with 1 mark out of 100 marks in your exam. So you should have to pay much more attention in your the answering and in your practices before exam, how to take the maximum marks in your MCQ paper. And then after, Actually, there is no any matter if you don't know the things. It's okay when you will mark the wrong answer. It's okay, but if you know the things and if you know all the chemistry concepts related to that question, but according to your careless mistakes, you will miss that correct answer. Then that is the thing that you have to get rid of. Okay, by using your practice before question paper, you have enough time. You can take high practice, large amount of practices with the examples, and then after you can reach for the high score. You can take high score in that paper. And actually here, these are not the fixed amounts of the questions based on the subject area. Actually, we are taking 5 categories in our syllabus: physical chemistry, general chemistry, organic, inorganic, and environmental and industrial chemistry. And these are the type of questions, number of questions that they are coming according to the categories which we have under our syllabus. Physical chemistry, we have roughly we are taking 18 questions, and 18 or 17, it can be 20 or like that around. It comes as physical chemistry. And when you go through this table, you can identify that there are they have given high attention, large attention for the physical chemistry. It is coming, you can prove it by using your the type of the questions based on your paper as well as your syllabus. Even they have given much more attention for the physical chemistry. So in your learning process also, you should have to give large attention, high attention for your physical chemistry and the exercises based on that physical chemistry. And then general chemistry is coming with the first 2 lessons. That means the atomic structure as the first one, and the second one is the chemical bondings. So in MCQs, there may be 9 or 10, like that type of a number of questions may be coming according to the general chemistry. And then after, organic chemistry is also giving large area in your syllabus, and number of MCQs are also coming around 12, 13, like that. Then the inorganic chemistry, SPD, which is in your 6th lesson in your syllabus, 7th or say 8, 9 questions are coming according to that inorganic questions, inorganic chemistry. And last one, environmental and industrial chemistry, they are giving 4 questions, around 4, they are giving that based on the questions based on this environmental and industrial chemistry. So this is how the 50 questions are categorized in according to the syllabus which we have gone throughout this teaching learning process. Okay, and then after, here they have identified some common shortcomings committed by students when answering a multiple choice question paper. They have noticed like this, because here if you have identified the shortcoming points before your answering process, you can get rid of that shortcoming and careless mistakes, and you can reach for a high score. You can take high score in your MCQ paper. First one is not understanding the basic subject matter clearly, leaving out. Then the second one is not reading and understanding the question well. You are very hurried to write the answers, but you are not giving any time to understand and read it properly. Okay, so because of that point, even you will miss some marks. And the third one is not reading the whole question. If you just looking at the question, and when you are saying that some sort of data are there, you will not cover all the data that they are giving in the question. You are using only 1 or 2 questions, and then two data that they have given, and you will take the answers, but the answer, it will be wrong, or otherwise you will take very not enough time. Okay, you will take a very large time in there. And then the thinking about time and not paying enough attention for the question is also coming as a shortcoming. Then the fifth one is not applying the principles of chemistry in relevant occasions. This is what you have to practice before your exam. Okay, we are learning chemistry concepts, we are learning chemistry principles throughout your learning process, but actually you don't, if you are not practicing how to apply those chemistry concepts or the principles that you are learned before your exam, you can't try on that exam. You should have to practice before the exam, and then after you can take high marks in your examination. Okay, so that is why you have enough time. Don't worry, you have enough time. And now the thing is, you should have to collect what are the things that you have already know and what are the missing points. Go through your syllabus and take out and mark what are the things that you have missed and what are the things that you have already know. If you have got any confidence in any subject area, you can take the past paper questions and other model paper questions based on that particular topic, and then after you can have the confidence on that part. Okay, so that is how you can train how to apply the principles of chemistry in relevant occasions. So overcoming the above drawbacks will help answer the question paper better. That is your target. Okay, then here paper number 2. Both papers are not giving in the same day. They are giving in 2 days. First day is the paper number 1 or paper number 2, and the second day is coming with the other paper. When you take about the paper number 2, it is coming with 3 parts. Part A is the structured essay. Okay, structured essay paper. When you take the structured essay paper, now this contains 4 structured essay. There are 4 structured essay, and you have already seen those type of question paper, and in your term test even they are giving this type of arrangement in your setup. And here paper number A, paper A, structured essay, they are giving enough sufficiently enough space to write the answers. So you don't want to take any extra papers to write the answers according to part A questions. Okay, and the number of questions are also already fixed in here. The structure number A, first question is coming with the general chemistry. General chemistry. Okay, so you know that general chemistry is coming with the first 2 lessons, chemistry. First 2 lessons, atomic structure and also the chemical bondings. So if you have covered the both lessons, first one and the second one, very efficiently, you may have high confidence to face the part A first question, and you are able to take at least more than 90 marks out of 100 if you have covered all the points which we are discussing under the general chemistry as your first lesson and the second lesson. Okay, and the second one is coming, second structured essay paper question is based on the inorganic question. It should be the inorganic question. Inorganic question. And then after, the third one is coming with the physical question. Physical question. And especially you should have to pay high attention in here, because both the question, both are coming with the practical sessions. Okay, you know that in these days we are unable to take the practicals, but somehow you should have to practice. You should have to develop your skills, how to take the practicals and what are the things that we have to concern in their practicals, and the observations. Based on that observation, how can we take the correct answer? Like those things you should have to practice. Okay, and based on your practical knowledge, I mean, it is not by hand. Actually, you can take the data, how to analyze the data and how to synthesize the answers from the data given here, there, like that ability you can take by answering the questions before your exam. So those things, those 2 questions are coming under this topic, inorganic and physical lessons, but they are based on the practicals. Sometimes they are giving the data and you are asking to write the do the calculations and analyze the data and identify the things and do the reaction, like that way. They can ask the second question and the third question, which is coming under the part A as a structured essay paper. And the fourth one is coming according to the organic lesson. Organic, you know, most probably it is coming with the isomerism. Isomerism should be there, and some simple identification of the types of the reactions, electrophilic addition, electrophilic substitution, like that way. According to your organic lessons, we have introduced the types of the chemical mechanisms in there, and you are able to identify what is the type of the chemical reaction which is going on. And then after simple conversions or otherwise simple reactions, 1 or 2 step reactions may be asked based on the 4th question paper. And the other thing is the mechanism, 1 or 2 mechanisms also can be there in your 4th question. Okay, then the third one, the part B. Part B is coming as, and both part B and part C, both of them are there in your essay paper. And you should have to use different paper, the separate papers, separate answer sheets for writing the answers in part A, B and part C. And part B is containing 5th question, 6th question and 7th question. All part B is coming as a physical part. Okay, physical based on these physical lessons, you should have to take these questions. And then the 5th question and 6th question can be the combination. You know that there are so many lessons in our physical session, from basic calculation, and then after the energetics, gases, then the equilibrium, kinetics, like those. There are so many physical lessons based on any area which you have covered under your physical category. And there can be a combination also. You can take 5th question and 7th question, and the 6th question and 5th question. 7th question is coming with the electrochemistry, that is also coming under the physical lesson. Electrochemistry question and electrochemistry question, and the other part electrochemistry question, and the other part is coming with the D block question. Okay, because both are coming also under the physical chemistry, because D block, it is coming as an inorganic session. We are giving some ideas based on the physical lessons also. Then those things are discussing under the, you have to, they are checking your ability to answer these type of questions under this physical category under part B. And part C is coming the other part. That means out of these 3 questions, you should have to select only 2 questions and answer as much as possible. 2 questions only, not to answer all the questions. Even you can do it, don't write all the question, all the answers for the all questions. Select only 2 as a maximum and write the answers in there. Then after the part C is containing 8th question, 9th one and 10th one. Here also you are asking to select only 2 questions out of these 2. Select any 2 questions that you can reach large marks in there. And then after, you know that 8th question is coming with the organic session, and the 9th question is coming with the inorganic, that means S and P, and the identification of the inorganic, and also based on the physical lessons, physical calculations are also going in there. And the 10th one is coming with the environmental and industrial session. Okay, so this is how your paper has been arranged. So if you have got a clear idea about your paper, I think you can face your answer paper very well. Then after, we will move to the other one. Here these are the facts considered when answering the question paper, and suggestions are given. Actually, I won't take any time to read this one. You can manage it. And here these are the special instructions which you have to follow when you are doing your chemistry answering process. Here basic thing is, in case of chemical equations need to be written, for reactions they must always be balanced. Okay, you are not giving any marks for unbalanced reactions. You should have to balance them properly. Even the reactants and the products are very correct, they are not giving the marks if it is an equation. Okay, then the physical status of reactions should always be indicated when required. Physical status always should be required for the physical lessons, and sometimes in inorganic sessions also you have to show that physical status, because observations, think about the observation, you have to say that the precipitations are going on or the gas is evolving, like that way you should have to state it by using the physical state. And every instance the physical quantities are stated, relevant units should always be given along with their numerical value. Okay, because you know that some sort of the marks are also given for the units, and actually the advantage of this writing units is one thing: you can gain marks, you can take the marks, as well as you can confirm that the process that you are going through is correct, because while you are doing the calculations with the numerical values, your units are also getting some calculations in there, so you can confirm that the method that you have selected for answering questions through your calculation is correct or not by using this point. Then when drawing Lewis structure or the Stressless structures, lone pair and the charges should be indicated very correctly. And as regards chemical calculations, more exercises should be done to promote the ability of solving problems using the skills related to the analysis and the synthesis. Okay, so these are the special instructions you should have to follow, and you have to keep those things in your mind, and then after you can take high result, very high marks in your examination. So now we will take the example. Actually, as a second session, we will look at the Vespa theory, because I told you not to here when you are starting your question answering process, you should have to be calm. You can't. You should have to be relaxed. Okay, when you are getting relaxed, sometimes at the moment that you are taking the paper, don't hurry to write the answers. First, you take your time and relax. Then after, start the point where you can do it. Okay, I think it's very better place is there in your first structure paper. For example, I am telling you about the second paper, structure part A. In there, you know that there is a part called Vespa theory, and the questions are coming based on the Vespa theory. And if you have gone through the question based on the Vespa theory and filling the chart which has they given, which has given by them, you can take much more enough time for answering them, and then after writing the answers for that, you will be settled down and you are able to take the other answers and you can take the answering process. Okay, so we will move to the other part in as a Vespa theory. Okay, now this is the Vespa theory, and this is coming under your second lesson, which is coming as the bonding. And here we shall go through the theory, and I think you already have got your the notes, but if you have missed something, just cover it, and don't want to take the time for writing the notes in here, because you already you have taken it and you got your notes very clearly. If you don't have, you can take the reference in your resource book even. And the special thing is you should have to apply the things that you have learned throughout this lesson. Okay, and that is most important thing. We will start our journey here. The Vespa theory. Actually, The basic principles of Vespa theory is the electron pair repulsion each other, repulsion of the electron pairs. Now here you should have to come out with the Lewis structure. Okay, when you take the Lewis structure, main objective to represent a Lewis structure of a molecule or an ion is to represent the number of valential electrons, how the valential electrons are arranged around the central atom or among the atoms inside the molecule or the ion. For example, we'll take an example like ammonia, NH3. Okay, then when you take the example NH3, most probably they are giving the arrangement or the skeleton of this molecule. It comes like this: hydrogen, hydrogen, and hydrogen. And already you are familiar with the Lewis structure of this ammonia. It comes with one lone pair. Okay, so this is how you can represent the number of electrons inside the valence shell among the atoms inside the molecule or otherwise the ion. Okay, you don't want to represent the co-electrons. That means the inner electrons are not represented by using the valence shell. You are only representing the valence shell electrons. And the other thing is, there are only two types to remain those electrons inside the valence shell. What are those? Those are the type of the bond pair. It can be inside the bond pair or otherwise it can be inside the lone pair. Okay, there is no any other ways to remain those electrons inside the valence shell. There are only two ways, in a bond pair or otherwise in a lone pair. Okay, and then after, you know, according to the electrons, all of them are even there in the bonded pair or the lone pair. Both of them are coming with the negative charges, and those negative charges are same like charges. So because of that, some electrostatic repulsion is going on in between those two electron pairs. Okay, so electron pair repel each other. Why? What is the reason? Because they are having same charges on themselves, and electron pair in molecules tend to arrange themselves so as to minimize the repulsion between them. So how they have been arranged inside the molecule or the ion, they should have to minimize the repulsion force which are there among themselves, and then that is how we can take the arrangement or the structure of the molecule or otherwise the ion. Okay, so that is how we can take the geometry, electrical pair geometry, or otherwise the shape of the molecule. Then here, now valence shell electron pair, there are two ways to represent the valence shell electron pairs: lone pair or otherwise the bonded pair. Lone pairs are there, they are not participating for the bonding, they are alone. And bonded pair means they have already participated for the bonding process. And you know that there are three types of bonding specially going on. Single bond, it can be single bond or it can be double bond, single bond or double bond, or otherwise a triple bond. Okay, so when you consider about the electron pairs which are coming inside the bondings, now here this one, even it is in single bond, there is an electron pair in here. In here also there is an electron pair, and here also there is an electron pair. So in between those two electron pairs also, they have got some repulsion force in between each other. They should have to repel from each other. But actually, if they have come in as a double bond, there is no any other option. Even they have got the repulsion force in between themselves, they can't keep far away from each other, because they have to build up the bonding in between the same two types of atoms in here. So that is why even the triple bond or the double bond or otherwise the multiple bondings are going on, they have got the repulsion forces among each other, but actually we don't have any option. We should have to take it as one unit for the repulsion force. Okay, so that is why in bonded pair, when you are considering about the bonded pair, you should have to consider only the five sigma bonds in here. You know that multiple bonds are coming with the sigma bonds as well as the phi bonds. Now, phi bonds, we are not mentioned about the phi bond in here because you have to take it as a one unit, because there is no any other option. Even they have got the repulsion force among themselves, there is no any option. They should have to keep together. So that is why we should have to count it as one repulsion unit. Okay, so here valence shell electrons, there are when you consider about the valence shell electrons, there can be you can count the number of electrons. They can be in lone pair or the bonded pair, but when it is turning into the repulsion units, you should have to think about the bonded pair, and you have to consider only the sigma bonds which are coming in the multiple bondings. Okay, so this is how you should have to take some idea about the valence shell electron pairs and the repulsion units, because all valence shell electron pairs are not coming as a repulsion unit. Okay, then after, if you have identified the types of the repulsion units, you are also identify the types of the repulsion forces which is going on in there. Lone pair repulsion force can be there, lone pair repulsion force, and then after the lone pair bond pair repulsion force, bonded pair repulsion forces. So these are the three types of repulsion forces which are going on inside the molecule or the ion. Okay, the other thing you should have to concern in here is the strength in these forces. Now, repulsion force which is given by the lone pair is much more than the bonded pair. So that is why if you have are taking the strength of this forces, repulsion forces, you can say that the repulsion force which is between two lone pairs are much more strong. It is very high strong, and it can give a very large repulsion force on the other one, and the lowest strength is there with the repulsion force which is between two bonding pairs, two bonded electron pairs. Okay, so this is how you should have to identify what are the valence shell electrons and how they are become as repulsion units, and then after identifying the repulsion forces and the strength of the repulsion forces which they can perform. And then after, now we will look at how those repulsion units are arranged around the atom in the molecule or the ion, and how we are taking the molecular geometry, or otherwise the electron pair geometry, and how the molecular geometry is coming out from the electron pair geometry. Okay. This is the Vespa theory called shapes valence shell electron pair repulsion theory. It is coming for the shapes of molecules. Now here, suppose you are taking one atom with two bonded pair. Here two another atoms are also should be there. You can just, when you are looking at the molecule, you can see the presence of these three atoms which are ending with a bond pair. Okay, now the bonded pair electrons, there are two bonded pairs electrons. So because of that, you can have there is a repulsion force which is going on in between those two bonded pair. Okay, so they are getting repelled from each other. Then how can they arrange as they are stable position to minimize the repulsion force which is given by themselves? So they can take it as a linear shape. Okay, you can see how it is getting arranged. So if you have got two repulsion forces in around one atom of a molecule or an ion, you should have to arrange them in a linear shape. Okay, examples are coming as even that, for example, when you take Here, this is how the repulsion force is acting on those the bonded pair, and this is how they will arrange in a particular manner. It is coming with a linear shape, and the angle of this one is 180. For example, beryllium fluoride BeF2 and carbon disulfide. Here also you can see that two bondings are coming in here in between carbon and sulfur, but actually we should have to consider both bondings or double bond as a one unit. Here, that is how you can say that there are two repulsion units around this carbon atom, and those two repulsion units have been arranged around this carbon atom as in linear shape. Okay, so this is how it comes. Here also you can see that a triple bond is going on in between carbon and nitrogen atoms, but actually we should have to take it together as one repulsion unit. So that is how you can say that two repulsion units are there around this carbon, and those two repulsion units have been arranged in a linear shape. Okay, when you are asking to write the number of electron pairs around this carbon, there are four electron pairs. Okay, four electron pairs are there, or four bonding pairs are there, but when you convert it into the repulsion units, you should have to consider about the concept that I have given earlier. Okay, so this is how, and here if you have got three repulsion units together around one atom, you can say that earlier it was there in linear. If you have got one more in here, you can see that it also given the repulsion force on the others. So the most efficient arrangement or very stable arrangement to keep it as low repulsion force among each other is a trigonal planar arrangement. And when you take the angle here around this one atom, it has 360 degrees. You should have to divide it by 3 because each bonding pairs are equal with each other. Because of that, evenly they can share 360 degrees, and one is coming as 120. Okay, that is one plane. There is one plane. You can keep it on your book or on one plane or on the table, like that way. There is only one plane is there. Then suppose that the three repulsion units are containing one lone pair with two bond pairs. Okay, the combination is going on one lone pair with two bond pairs. Then actually when you're looking at the molecule, you can see the presence of the atoms in here in as a middle, and here and also here. Okay, then so when you are looking at the molecule, you can see a different shape rather than the electron pair geometry. When you are taking the electron pair geometry, you should have to come out as a trigonal planar, but actually when you are looking at the molecule, you can't see the presence of the lone pair, but actually it is working out. Okay, you know that it is giving some effect. So when they are giving their effect, the arrangement should become as a trigonal planar. But when you are looking at the molecule, you can see the shape of the molecule because of the presence of the atom which is in here as a center, and the ending of each bonding in here. So that is why the angular shape or V shape is coming as the shape of the molecule. And because of the high repulsion force which can be given by the lone pair, it gives much more repulsion force. It gives the force on this bonded pair, and here also they are giving much more repulsion force on the bonded pair which is in here. So that is why the angle is getting smaller than the typical was 120, but because of the high repulsion force which is given by the lone pair, the angle is getting little bit lower than 120. And the other thing in here is you should have to come out with the value. Okay, now they are not giving the marks for the writing when you're asking the what is the angle of oxygen, oxygen and oxygen, oxygen in here, when you're asking the angle like this, they are not giving you the marks when if you are writing 120 and it is less than 120. Okay, this one is not giving marks. You should have to mention it with the correct value. It can be rather than 116 or 117 or 115. It can be there. You can write any number which is lower than 120, but it should not to be lower than 150. It is impossible. Okay. So this is how it is going on. Still they are in the they are using one plane. Now the tetrahedral arrangement, it has got 4 repulsion forces, 4 repulsion units around one central atom, and when they have got 4 repulsion units, you can see how it is coming from the trigonal planar, that one is giving force on the other 3 and they are getting low down. Just like a mic stand, you can see that the tetrahedral shape or geometry is coming out. The shapes which are deriving from the tetrahedral is coming with the combination of the lone pair and the bonded pair. Now already you have got the 4 repulsion forces. If that 4 repulsion forces are coming with 1 lone pair with 3 bond pair, you should have to arrange it like this way. Okay, and here the geometry is still the tetrahedral, but when you're looking at the molecule, you can see the shape of this molecule, and when you're looking at the molecule, you can see the presence of the atoms inside the central of the atom and after the ending of each bond. So if you are taking the shape, it is coming out from the geometry, because you can't see this one, but the same the derivation from the geometry, electrical geometry, the shape is coming as trigonal pyramidal. Okay, you should have to write it very clearly, trigonal pyramidal. If you have written only the pyramidal, sometimes they won't give you the marks, because there is another type of pyramidal is coming here, score pyramidal. So if you are writing the pyramidal, you should have to mention which type of pyramidal is there as their shape. Then as a typical tetrahedral shape, they will have 109.5 degrees, but if they have got if they are taking if they are taking one arrangement in here, it will reduce that angle up to 107 or 106. Okay, you should have to come out with the correct amount, not to write less than 109. You should have to write the correct angle in there. And here see, now if they have got 4 repulsion units are there still, and if you got 4 repulsion units, it's a combination with 2 bonded pairs with 2 lone pairs, you can see that a large amount of repulsion force can be given by both lone pairs. Because of that, the angle is getting reduced, rather than the 107, even 104.5 is coming as a the angle in here. You should have to write with the unit, with that amount. Okay, not to write less than 109, because you can have give any number in between 109 or in here in between 107 up to 102 or 103. Okay, don't write any angle which is lower than 100, because it is impossible. You should have to write the correct value. It can be varied in between that two numbers. Then here, this is the way that you are taking the arrangement of the 5 repulsion forces. 5 repulsion forces are coming like this, and they are arranging like this. So the geometry is coming out as a trigonal bipyramidal. Okay, trigonal bipyramidal. When you look at the molecule, you can see that 3 repulsion forces are there in one plane, and 2 of them, 2 other are coming as a perpendicular to that plane. Then this is how 2 pyramids are getting together. Okay, So for example, when you take the phosphorus pentafluoride, it comes like this. Phosphorus pentafluoride, five repulsion forces, 5 bondings are coming in one plane and 2 are coming in here. Then after the other arrangement from which are deriving from the trigonal bipyramidal is a seesaw. Actually in here, when you set that lone pair in here, in this plane, there will be a repulsion force. Large amount of repulsion forces are coming in here. 3 repulsion forces are acting on here, but it is impossible because you can reduce the repulsion force which is given by that lone pair when you have arranged it in this way. Okay, now when you have arranged in this way, it has only 2 repulsion forces. 2 are acting on here. So that is why when you are taking the lone pairs, you should have to take it in the plane. Okay, when you have taken it like this arrangement, you can see that seesaw arrangement or seesaw shape is coming from the geometry called trigonal bipyramidal. Then the angles, typical angles are also getting reduced. Here, when you have got two lone pairs with 3 bonded pairs for the 5 repulsion units, it will be arranged in the T-shape like arrangement. Okay, and when you have got 3, 1, 2 are there in a linear shape, so it is coming as 180. Okay, for example is also given. Then the octahedral arrangement is coming with 6 repulsion units. So this is how it coming. 4 are arranged in one plane and 2 are coming just perpendicular to this plane, but actually the arrangement is all over the molecule, it is same. So whenever you set that lone pair in anywhere, the same repulsion forces are going on. So you can take it, and when you have derived that shape from the octahedral with 1 lone pair with 5 bonded pair, it is coming as quapyramidal, and 2 lone pairs with 4 bonded pair, it is coming as quaplanar. Okay, and here this is the arrangement XeF4 xenon tetrafluoride. The bond angle is coming as 90 degrees. Okay, then next one, you should have to take the hybridization also. That hybridization part is also coming in here in your the paper, because that is another part actually. But when you take the hybridization, easily you can identify the hybridization which is going on according to their geometry, or otherwise the number of repulsion forces, repulsion units in there. Okay, so when you take that repulsion unit, here when you have got 4 repulsion units, you know that 4 repulsion units are coming based on 4 hybrid orbitals. So 4 hybrid orbitals are coming because of the sp3 hybridized orbital hybridization. Okay, so if you have taken the number of repulsion units from that arrangement, or if you have taken the geometry, electron pair geometry, easily you can identify the type of the hybridization which is going on that particular atom. For example, you have only 3 types of hybridization: sp, sp2 and sp3. There are only 3 types of hybridizations. So if you want to identify what is the type of the hybridization which is going on, you should have to count the number of repulsion units, and if they have got 4, you have to mark it as sp3 hybridization. If it has 3 repulsion unit, it is coming from the sp2 hybridization. And if it has only 2 repulsion units, you should have to mention that the hybridization should be sp. So like that way, you can identify the hybridization also going on in that particular atom. Then after, we will come with an examples. Here we will take an example for NH3. When you are writing, I'll write an example NH3. So if you have come in with the Lewis structure, I don't want to teach you how to take the Lewis structure. That is another part. From another session, we will discuss how to write the Lewis structure and the resonance structure. Now, if you have taken the resonance Lewis structure from here, don't worry, in your paper, you are giving the correct Lewis structure, and based on that correct Lewis structure, you are asking these questions. So here, number of electrons. Now, actually, when you are asking to predict the shape, you just want to writing the shape is not enough to gain the maximum mark. You should have to show how can you take that shape from the prediction. Okay, so that is how these steps should be going on. You are giving the marks for each steps in here. And here the repulsion, first of all, you can count the number of repulsion, the electron pairs. Here 1, 2, 3, 4 electron pairs are there. All of them are coming as a repulsion unit. So number of repulsion units, you can take it from there. It is 4. Then after, even you are not giving the marks for the prediction, for the geometry and the hybridization, it's better to write the geometry and the hybridization in here. At the same time, you can think about the geometry and also the hybridization of the atom whenever you have think about the repulsion units here. So the geometry is coming for repulsion units. Geometry, electron pair geometry is coming as a tetrahedral. Tetrahedral. Okay, then the hybridization, because of the 4 repulsion units are coming out from the sp3 hybridization. Okay, then after you have to think about how these 4 repulsion units are getting combined with each other. It is consist with one lone pair with 3 bonded pair. Then after, you have to take the shape which is deriving from this repulsion units, the geometry. You have to think about this one, and you have to arrange it in the trigonal pyramid. Trigonal pyramid. There. Okay, and then after, when you are asking about the angle, you should have to write not to write less than 109. It's better to write 107 or 108, less than the value which is coming less than 109. You have to write it like this. Okay, and then after, we will take another example. If you also want, you can give me an example, and then after, we will try on these questions. Then we'll take NO2 plus. All of you can practice with me. NO2 plus. Here, when you arrange it in the Lewis structure, the Lewis structure is coming like this way. Oxygen, you know, you should have to represent the presence of the lone pairs on each atom when you are taking the Lewis structure. Then plus charge is there on this nitrogen. Okay, then after, how can you take the number of electron pairs around one atom? This nitrogen, it has got 4 electron pairs, and when you are thinking about the repulsion units out of these 4, how it has arranged, you should have to take two repulsion units, because in your previous session we have discussed, you have even that 2 electron pairs are there together, you have to take both together as one repulsion unit. So that is why you should have to count the number of repulsion units around this nitrogen atom as 2. Then after, the geometry is coming with the 2 repulsion units. It is coming as a linear. Then the hybridization, out of sp3, sp2 or sp, you have to take only one out of those three. It is coming with sp. Okay, then these answers are using for other questions, but if they are asking to predict, you may not giving the marks at this position, but you can think at that moment when you are thinking about the repulsion units. Then after, you can take the answers which you have taken from here. Then the number of bond pairs in here, bonded pair, here also you can't write it as 4. You should have to write the bonded pair which has considered as a repulsion unit, so it should be 2. Then the lone pair, there are no lone pairs. Because of that, the shape and the geometry both are same. It comes as linear. And the angle is 180. Okay. One more thing, we shall take SCl4. SCl4. Then I'll write it like this: Cl, 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 and suppose that you have asked this type of questions in your MCQ, don't want to take that calculation process and take the structure of the Lewis structure from the calculation. By practice, you should have to draw that, and in MCQ you don't want to show that the lone pairs, but in here, if you are asking to draw the Lewis structure, you should have to come out with the lone pairs in terminal atoms also. Then when you take the number of electrons in the valence shell of this sulfur, 1, 2, 3, 4, then 5, 6, there are, that sulfur is in 6th group. 6th group means they have got 6 electrons. So 6 electrons should be should be there. You have to represent that 6 electrons. You have keep 4 in bonded pair, so 2 will be remain in a lone pair. Okay, so this is how it is coming as the arrangement of the Lewis structure of SCl4. Then after, when you go through these points, number of electron pairs around that sulfur is 1, 2, 3, 4, 5. Then here you have to think about all these electron pairs are also coming as the repulsion units. Yes, it is. There is no any multiple bondings in here, so it is also coming as a 5 repulsion units. Then after, you know about the geometry which is coming out from the 5 repulsion unit. The geometry is a trigonal bipyramidal. Okay, trigonal bipyramidal. Then the hybridization, actually you are not asking about the hybridization when it is coming out from the 5 repulsion units. You are asking only sp3, sp2 or sp hybridization. According to your syllabus, you don't want to think about the dehybridization. So if they have taken like this, they are not asking about the hybridization based on this one. Okay, don't worry. Then the bonded pair is coming 4 bonded pairs with 1 lone pair. So 4 bonded pairs with 1 lone pair. If you have got this combination 4, 5, you will derive a shape from the geometry which is coming in here. So the shape which is coming with 4 bonded pair with 1 lone pair is coming as a seashore shape. Okay. Then the angle is also, that here this trigonal planar, it comes as 120, but because of this lone pair repulsion, it will get reduced the angle from 120, and these two angles are also getting little bit closer to the other one. Then so that is how you can take any simple molecules, and you can practice how to predict the shapes of the molecule or an ion around one central atom. So here you have to talk about the number of electron pairs and the number of repulsion units, and then after thinking about the number of repulsion units, at that moment you can take the geometry as well as a hybridization of the atom even, and then after you should have to take the how those number of repulsion units are there, how it has been arranged by using 4 bonded pairs with 1 lone pair. Then after 4 bonded pair with 1 lone pair or any other lone pairs are coming instead of this bonded pair, you will derive some shape from the geometry, and the angle is also you can manage it. Then we will move to the past paper questions because I'll show you. This is 2021 A-level paper. It is coming in your first structured essay paper. So actually it is they are giving the correct Lewis structure and asking you this type of chart. So before you are answering the questions which are coming in A part or B part, the resonance structure, Lewis structure, like those things, it's better to write the answers which are in here, because you will have high confidence in here to take that Vespa theory and the geometry and also the shapes of the atoms. Like that way you can think about those things and you have got high confidence in there. So if you have if you are starting your answering in here, you will get high confidence and you can settle down very easily and you can face for the other questions very easily. Then for example, when you take this question here, the Vespa units pairs around here, this is the correct structure that they are giving. Then based on this N1 is the atom that they are considering about. So when you count the number of valence shell electron pair units pairs are there, you can take here around N1, it has got 1, 2, 3 repulsion units. Okay. Then after the electron pair geometry, according to that repulsion, 3 repulsion units, you can arrange it in the trigonal planar. Trigonal planar. You should have to write it correctly, even that the space given is not enough. However, you should have to write it trigonal planar. Okay. Then the shape around this atom, you know that if they have got 1 lone pair instead of that 1 pair, you may have that the shape, derive that shape which is coming from the trigonal planar. It is angular. And according to the number of repulsion units, you can think about the hybridization in here. 3 repulsion units are coming with sp2 hybridization. Okay, so then after you can take the other one, carbon 2, second carbon they are given. So in here also you can go to the resonance structure, the Lewis structure that they have given. Then you can find that 3 repulsion units are there around this carbon atom. Then the same geometry is coming because of 3 repulsion units are there around that carbon atom. It is also the trigonal planar. Then the shape is not coming, the derivation of from this trigonal planar, because they do not have any lone pairs on it. Because of that, the same shape is coming as the geometry which is mentioned in here. So you don't want to write the comma. It's better to write the answer in word, trigonal planar. Okay, then the hybridization is coming according to the base of the Vespa theory. It also sp2. Then after the third one, it is carbon 3. It has got 2 Vespa units. 2 Vespa units are there around 1 carbon atom. 2, and the geometry is coming as linear. And the shape is also coming as linear because there is no any lone pairs. And the hybridization is coming as sp2. sp. Okay, you remember you are giving only 3 hybridization, sp2, sp or sp3. sp3 is coming from 4 repulsion units and sp2 is coming from 3 repulsion units and sp is coming from 2 repulsion units. That's all. Then last one, n4. Here around this n4 it is also having 2 repulsion units. Then the electron pair geometry is coming as linear. Here also the shape is also coming as linear and the hybridization is sp. Okay, so you can use these answers for your answering the other thing. Here even it has not clear, you can go to your paper in there, and here they are asking you to take the sigma bond hybridized orbital, or you are asking to write the hybridized orbital or otherwise the atomic orbital which are coming to make this bond in between nitrogen and fluorine in here. Okay, and you know that you can take the atomic orbitals in terminal atoms, or otherwise according to the number of repulsion units you can take the hybridized orbitals also. So in nitrogen it has a middle one, you should have to take the hybridized orbital from there in order to make that 5 sigma bond in here. So n1 is coming with sp2. sp2, you should have to write it very clearly. You can take it from here very easily, don't want to think it again. And fluorine is a terminal atom in here, so you can take that terminal atom according to the number of repulsion units around this fluorine. You can take it as sp3, or otherwise if you are thinking that because of the terminal atom you can take the atomic orbitals also. But if you are taking the atomic orbital, actually you should have to write the correct position of the atomic orbital. For example, you know that p is involving in here, but you can't say it just p, you have to say it as 2p. Okay, otherwise it is not valid. So this is how you should have to write. You can write sp3 hybridized orbital or 2p atomic orbital. Then after the next one, n1 is coming here. N1, this hybridized orbital is sp2. Again you can write it as sp2 because you can take it from here.
Miss Mute වෙලා.
Okay, you can take the hybridization on carbon in here because it is coming as sp2. You can take it from here, it is sp2. Okay, you don't want to you don't want to waste your time to think it again. You can take the answers from here which you have filled in this table. Then after the carbon 2 again, carbon 2, it is also coming with sp2 because you know that hybridized orbitals are coming for the making sigma bond. So sp2. And hydrogen, they are asking about the hydrogen in here. You know that hydrogens are coming with 1 electron in their bonding. It is in there in that 1s. If you have mentioned it as s orbital, it is not valid. You are not giving the marks for just s. You should have to write it as 1s. Then after the next one again sp2. sp2 is coming as the carbon 2, it is sp2, and carbon 3 you have mentioned it here, it is sp. Then after the next one again it is carbon 3, so sp is again coming. N4 is also coming with sp hybridized orbital. Then the N4 again sp, And here oxygen again is coming as a terminal orbital. So the terminal orbital can come with the hybridized orbital or otherwise the atomic orbital. If it is hybridized orbital, you can take it from the number of repulsion units around that oxygen. It has got 4, so sp3 hybridized orbital can be involved in here, or otherwise you can take it as an atomic orbital. If it is an atomic orbital, the particular atomic orbital should be 2p. So you are giving the marks for any of those two, but you have to write it correctly, 2p. Okay, so you can think that you can gain enough marks very easily because you have filled this table very correctly with the concepts that you have learned, Vespa theory. Okay, actually they are giving 12 marks for this one out of 100, and here you will get 16 marks for this one out of 100. And then after, before writing these answers in here, you should have to confirm that they are asking about the sigma bonds. If they have asked about the 5 bonds, you can't write the hybridized orbitals. You should have to write about the non-hybridized orbitals which are involving here. So first, before you are writing the answers, first read the question properly and identify what is the type of the bondings that they are mentioned about in your question. For example, in here, in this next question, they are asking about the 5 bond. Okay, so you know that 5 bonds are coming out from the non-hybridized p orbital. So just when you are writing that p, it is not valid because you know that p, it can be there in 2p, 3p or 5p, like that. There are so many types of p orbitals are there. You have to mention that the particular p orbital which is involving in this 5 bond, so you should have to write it as 2p. Here also 2p, here also 2p, like that. All of them are coming with 2p, but you should have to think it first and then after write the correct answer. Then the next question, they are asking about the bond angles in here. Even that question is not clear. State the approximate bond angles around N1, C2 and C3 and N4. That is, N1 is here. N1 is here. N1 is here means the angle they are asking about is deriving from 120. So the angle should be 118. Okay, you have to write it as 118. If you have written it as less than 120, it is not acceptable. You are not giving the marks for that one, because actually you can say that less than 120 means there is no any limit. It can be less than less up from 100 even. It is not possible. So that is why you should have to take the limit or otherwise a correct amount. Then the carbon 2 is coming as 120, or it can be more than 121, 121 or 119 can be in there. And here also 118, because it is coming as a linear shape. Then the next one is also coming as 180 because it is coming from linear shape. Okay, so this is how you can follow. You can answer the questions. Actually, this one is also coming with 4 marks, and here it will give 6 marks for this one. Okay, finally when you count it together, here 10 marks like this, 10, 20, 22, 32, 32 and 38 marks are coming out of 100. So actually, if you have if you are writing the answers for this question first, you will be you will have a high confidence to write the answers the other questions also, because easily you can collect the marks in this question. Okay. We will move to the other one also. Then next one is 2020 A-level paper. They are also having the same type of question in your first structured essay paper. Here the correct Lewis structure has been given in there, and you are asking the same points in here. clearly write these things in here. Don't get hurry and write the correct things. And because these answers which are you are writing in here should be very important to write the answers in here also, because they are giving very high marks, at least 1 mark for one answer. That is why you can collect the marks very well, and you can take it as your maximum. Okay, don't make any careless mistakes. You can take the maximum marks from this topic, which is coming as a Vespa theory. Then here, when you take, we will do this one also, because here N1 around this nitrogen atom, it has three repulsion units. So you can write it, 3 repulsion units. And you know that trigonal planar, 3 repulsion units have been arranged in trigonal planar. You can write it, trigonal planar. And then after, the shape is also coming from the geometry, because it is not differentiate from the geometry. There is no any lone pair on it, so you can write the same shape in here as a trigonal planar. Then the hybridization is coming on the sp2, because 3 repulsion units are coming from sp2 hybridization, so easily you can write it as sp2. Then the next one is also coming with 3 repulsion units in 2. Here N2, 3 repulsion units, but actually if you have got 3 repulsion units, they are arranging according to the geometry as trigonal planar, but the shape is deriving from there because of the presence of a lone pair on here. So you can take that the lone pair is there, because of that the shape is deriving from there as angular. Then the hybridization is also sp2. Then the oxygen, it has 4 repulsion units. 4 repulsion units have been arranged according to the tetrahedral geometry. You can write it, and because of the 2 lone pairs instead of 2 bond pairs in there, you can derive a shape from the geometry. It comes as angular. Then the angular 4 repulsion units are coming out from sp3 hybridization. Then next carbon atom, it has got 2 repulsion units, and the linear is the geometry, linear is the shape even, and the hybridization is coming as sp. Okay, so if you have taken the answers for this one for the hybridization, easily you can identify the particular atomic orbital or the hybrid orbital which is forming the sigma bonds in between these atoms. So chlorine, you can take it from the hybridized orbital, or otherwise you can take it from the terminal orbital. You can write it as sp3 according to the number of repulsion units around this fluorine. It has 4, so you can take it as sp3. Or otherwise, if you are thinking about the terminal atom, and you can take the atomic orbital even, so the answer is coming as 3p. Okay, you can't take it as 2p, because you know that the particular atomic orbital which is involving for this bonding is 3p. Then N1 is coming with sp2. You can easily take it from here. Okay, if you have managed your answering process very clearly and very efficiently, you will not waste your time, and you can have the very particular arrangement in your answering. And sp, you can take the maximum marks from here. Then here also sp2, here again terminal atom, so you can write it as 2p. If you are writing the atomic orbital, write the correct atom in there, then sp3. Here sp2, here sp2. Like that way easily you can fill it. And then after here think, now identify the atomic orbital involved in the formation of 5 bonds. Here also, that is why I told you not to hurry hurry to answer the questions. First read the question properly, because if you have asked the 5 bond, it is different, because you are using the non-hybridized p orbitals in order to make the 5 bonds, and there you have to write that particular p orbital. You know that non-hybridized p orbitals are involving in the 5 bondings, but just if you have written just p, it is not enough to take the marks. They are not giving the marks for just p. You should have to mention which p is it. it should be 2p. Like that way you should have to write it correctly. Okay. Then after the angles are again asking, so you can take it from the previous sessions we have discussed about. Typical angle is coming from the geometry, and you can have some reduction of that amount because of the presence of lone pair. For example, when you are taking angle shape, suppose that angle shape is coming deriving from the trigonal planar as well as it is deriving from the tetrahedral. Both are coming, the angle shape is angle, but the amount is different. Here the amount is 118 or 117, like that way it is coming because it is deriving from 120 as the typical. When you take it from the tetrahedral, the amount of the angle is coming as 100 and the 3 or 105, like that, because it is coming from the typical as 109 degrees. Okay, so this is how you can take the answers in this question. They are giving this type of question, definitely they are giving, so you can ready for this question by high confidence, and you can take maximum mark for this type of question. Okay, and there is another question in 2019 even. You will take your time and get practice on writing the answers in very short period of time. When you practice more and more, you can take you can gain marks, maximum mark. You will reduce the careless mistakes, and not only in here, in your MCQs even you may have the questions based on this theory. Okay, then that's all about this, and I think you can comment what you have gained throughout this lesson. Okay, good luck. Thank you. I'm giving the chance for the nano powder, and thank you for nano powder. Okay, thank you all. Good luck.
Being a chartered engineer, acquiring membership from certified management accountants supported me immensely to become a chief executive officer of a reputed company. CME is not only producing professional certified accountants, they have been developing their skills through continuous professional development programs. CMA is keen to develop their communication skills as well through their CMA program.
CMA for creating the pathway to being a well-recognized management accountant.
බොහොම ස්තුතියි මැඩම්. අද තිබ්බේ කෙමිස්ට්‍රි දේශනය. ඔව් කියන්න ඕනේ නැනපවුල් නිර්මාතෘ ප්‍රබන්ධ තිලකරත්න මහතාගේ සංකල්පයක් යටතේ ක්‍රියාත්මක වන මෙම දේශන අපේ නැනපවුල් ෆවුන්ඩේෂන් එක තුලින් සංවිධානය කරන ලබනවා. අපේ නැනපවුල් ෆවුන්ඩේෂන් එකට ලංකාව පුරා විවිධ පාසල්වල ආචාර්ය මණ්ඩලය එකතු වෙලා ඉන්නවා. ඒ වගේම කියන්න ඕනේ මේ වගේ කලා, වාණිජ, තාක්ෂණ, ගණිත, විද්‍යා යන අංශ සියල්ලටම ඉංග්‍රීසි, දෙමළ, සිංහල යන මාධ්‍ය තුනින්ම දේශන සංවිධානයකට තියෙනවා. ඉතින් අපේ YouTube channel එක ගැන කියන්න ඕනේ. ඔබට අද මෙම දේශනයේදී අතපසු කිසියම් හෝ කරුණක් තිබෙනවා නම් නැත්නම් අද පැමිණීමට නොහැකි යහළු හෙළියන් ඉන්නවා නම් අපේ YouTube channel එක ඔස්සේ ඉදිරි දේශන නැරඹීමට හැකියාව තියෙනවා. ඒ වගේම අපේ YouTube channel එක නිකම්ම වීඩියෝස් බලලා යන්න එපා. channel එක subscribe කරන්න, comment කරන්න, like කරන්න, යාළුවන්ට share කරගන්න අමතක කරන්න එපා.
අපේ Instagram account එකද follow කරන්න අමතක කරන්න එපා. ඒ වගේම ඉදිරි දේශන දැන ගැනීමට ඔබට හැකියාව තියෙනවා මම පහතින් කියන නම්බර් එකට Telegram ඔස්සේ message එකක් දාන්න. මොකද අපේ Telegram group එකක් තියෙනවා ඒකට සම්බන්ධ වෙන්න. 071 725 735 මම ආයෙත් කියන්නම් 071 725 735 කියන නම්බර් එකට ටෙලිග්‍රෑම් ඔස්සේ මෙසේජ් එකක් දාන්න. එහෙනම් මෙම හරවත් දේශනය පැවැත්වූ කශිකා මිස්ටර් බොහොමත් ස්තුතිය ප්‍රකාශ කරන අතර අප තවත් දේශනයකින් නැවත හමු වෙමු.